about chemical reactions. So the first thing we're going to do on that page, on page 46 that you're on, is at the top we're going to put a spot, because there are some specific things in chemical reactions that are always there when you write out the equation for it. And when I'm talking about writing out a chemical equation, I'm talking about like doing H2 plus O2 turns into H2O2 and 2 like that. So when I'm talking about this is a chemical equation, and this is what we're going to start with today. And in these things, there are always some typical or ordinary things that you'll see in here that I'm going to give to you. So on the top, you're going to have like a little key for chemical equation symbols and stuff like that. And you can put like a little box around it or some colors around it or something like that to set it off. That way you can always have the same spot to refer back to inside your notes. So first thing you got to know is that that little arrow, which is in all chemical equations right there, means something. That is the divider in there between the left and the right side of the chemical equation. So on the left of that, you've got the things that you're mixing together. On the right of that, you've got the things that it's making. So what this arrow means, in the literal sense of the word, is creates, is how you read that when you do that. So it's like in a math problem, you know, when you've got 2 plus 1 equals 3. This is the divider. The equal sign is the divider between the left and the right side of it. In a chemical equation, this is like the equal sign of a chemical equation, basically, is what that means. Uh-oh. Just grab a piece of paper today, a blank one, and we'll tape it in there. Where's the third of your group that went out there? Oh. Shayla does. Okay, next one that you got to know are these 3 symbols that go along and in there. And in a chemical equation, like this one up here, after the elements are listed, you'll see stuff like a G after it, or a G, or a L. And that just refers to what state it's in, whether it's solid, liquid, or gas. That tells you what state it's in. So you'll see those little symbols after it. And they don't really mean much in terms of what we'll do with balancing chemical equations and that, but it tells you, like, are you mixing solids, are you mixing liquids, or are you mixing gases together? So make sure you get a piece of paper that you can get this stuff down on if you don't have your notebook here today, so that you can take it and paste it in there. So next symbol we've got is right there. You can see it. It's that little up arrow. And sometimes you'll see those in a chemical equation, and that represents that is giving off a gas. So the thing being given off is like bubbling away as a gas. So it's like as you're reading a chemical equation and it gives off a poisonous gas, you make a little note of it. Like here's a little arrow to tell you this is bad and you don't want to be around it. So it gives you a little arrow to remind you that there's gas given off. So those are kind of the 3 things, 3 big things. The create sign, solid, liquid, gas thing, and then the gas given off piece. The last 2 bits you might remember from like 6th, 7th, or 8th grade science whenever you had it. And that is what you call stuff on the left side of this arrow and on the right side of the arrow. So in a chemical equation, the name of the stuff you mix together. What's the name of the stuff you mix together in chemical equations? I say it and you're going to remember it probably. You remember the word reactants? Yeah. So stuff on the left-hand side of that arrow are called reactants. And those things are like the ingredients in a recipe. If you want to think about a chemical equation like a recipe to produce something, things on the left side of it would be the ingredients for it. So if you're making chocolate chip cookies, you'd be talking about flour and eggs and sugar and chocolate chips and butter and baking soda and stuff like that. All of those would be the reactants. And then now that you know the word reactants, do you remember what the stuff on the right-hand side of the arrow is called? Products. Yeah, very good. So on the right-hand side of that arrow, those things are referred to as products. And those are like the results of it. Yeah, sorry about the spelling. So right side, products, those are things that are produced or made in a chemical reaction. Like in this one up here, if you combine hydrogen gas and oxygen gas, you produce water. So These are reactants. These are products. What's that, Shayla?
Candy.
No one else is on the same page with you right now. I'm sure that was totally relevant. And, what is what? Candy?
Yes, it's a chemical reaction.
As you digest it?
No, as a potato.
Okay. Okay. Trinity?
Okay, on the picture, shouldn't the plus, like the 2H2 plus O, shouldn't it be like, there shouldn't be a 2 there because water's just H2O?
Here?
No, like...
Notes. Make sense? So a little key. Right next to that chunk that you just wrote down, you're going to have a chunk for these 5 types of reactions that we're going to pop up here. These are the 5 that you are going to be responsible for knowing and identifying as we go through and take our test. I'll read them to you. They are synthesis, decomposition, single displacement, double displacement, and combustion. These things, like it says under that. Yep. You're going to need to be able to not only memorize the names of them, but be able to look at a chemical equation like this one up here and tell me which of these 5 it is. Tell me which of those 5 things it is. So going through the first reaction. So you don't have to write synthesis reaction again because you've already got it written someplace. You can just write number 1 now instead of having to write synthesis reaction. You can write number 1. To describe it in words, it's described like this. It's when 2 elements combine to form 1 compound. So 2 elements combine to form 1 compound. And in words that might not make a lot of sense, but I can make it make sense to you here in a little bit. For instance, are represented, we can use a hand symbol to represent those things. If you think of 2 things together, coming together to form 1, it looks like this with a synthesis reaction. 2 things coming together, you can think about it like that. I'll show you what it looks like in terms of a chemical equation here and what the key is. The key to this is right here. In a synthesis reaction, this is the only chemical reaction that does this. It is the only chemical reaction that only has 1 product. There's only 1 thing on the right-hand side of the chemical equation. This is an example of a synthesis reaction. It only has 1 thing on this side of the chemical equation. Same thing. This is a synthesis reaction. The key to this is, can you see how there's only 1 thing on the right-hand side of that arrow? There's only 1 product. And that's the part you want to highlight, because earlier I said you're going to have to be able to look at one of these things and tell me what type of reaction took place. That's how you do it. Synthesis reactions have 1 thing come out of them like that. Sorry. So what I did is I found a picture that I thought represented a synthesis reaction. And what I'm going to ask you to do here in your table group is come up with an idea for a picture that you guys are going to put on the page 45. You're going to divide 45 into 4 equal boxes. So in your group, you're going to come up with and plan out a picture that's going to represent a synthesis reaction that you can use to represent a synthesis reaction on there.
4 boxes?
4 boxes. So a line down the center and a line across the center, and you got it. On page 45.
Wait, a picture or a formula?
Picture. So, here's my picture, and here's how I represented it. You don't get to laugh at my artwork, because it took me a long time.
Wait, this was on the first box?
You're not putting my picture in there. This is my picture. You're going to come up with your own. Here's my version of a synthesis reaction. 2 things come together to form 1. You've got a skinny bird plus a big fat worm, and when it eats it, it makes a BFB, a big fat bird. So, 2 things merge together to form 1, right? 2 things together to form 1, like that. What I'm going to have you guys do, thanks, at your table groups, and Rylan, you can jump with these guys today if you'd like. Or Rylan, Naum. I know. Naum, what you can do is you can jump in with this group if you'd like today. And what I want you guys to do, and I'm going to give you 3 minutes to do this, is come up with something. You're not going to draw it yet, but I want in your groups, in your notes, everyone in your table group to come up with a picture and then an explanation of why your picture represents a single or a synthesis reaction. Make sense? Okay. On your list, which was a decomposition reaction. So that's number 2. No, the drawing part is so you're planning it out now, and then the drawing part's the part you're going to take care of when you leave class. So decomposition reaction is exactly the opposite of a synthesis reaction. A synthesis reaction is like two things come together like this. A decomposition is when two things break apart into the things that like make them up. So they're exactly the opposite. Synthesis brings stuff together. Decomposition breaks it apart. Like think about the term decompose. What does it mean? Yeah, breaking it down. So in chemical reactions, usually what happens is you can apply heat to something and it'll break it down, or sometimes you can use another chemical to break it apart, like speed it up. But the term is decomposition reaction, and a decomposition reaction occurs when a compound, and a compound is two elements put together, breaks up into the elements that make it up. So decomposition occurs when something breaks down into the elements that make it up. What it looks like, and the part you want to highlight for this, is that it is the only chemical reaction that we'll deal with that only has one reactant, which means it's only got one thing on the left side of the arrow. That's your clue for a decomposition reaction, right? It's flipped from what a synthesis reaction was. A synthesis had two reactants in one product, and this thing's exactly the opposite. So it's a decomposition reaction. Here's some examples of decomposition reactions that we've got on here. It's the opposite of that, which is where we turn hydrogen and oxygen into water. You can turn water back into hydrogen and oxygen by passing like an electric current through it, with two separate, like an anode and a cathode. And when you do that, you can conduct a decomposition reaction. That stuff breaks down and turns into this. Another example is with magnesium oxide or mercury oxide. You can do the same thing. You can produce liquid mercury in oxygen gas. Right on. So that's a decomposition reaction, and the one thing to remember is the key to identify it, and that is that there is only one reactant. So if there's a part you wanted to highlight, underline, star, whatever, it's that in these there is only one reactant on them. So my picture, and then you guys are going to do the same thing. You're going to plan out. You're not going to draw it yet unless you can fit it in the 3 minutes that I give you to do this. You and your table group are going to plan out a picture and write down the details of it so that when you go home you can draw it. But you're going to plan out a picture that represents a decomposition reaction, which is going to show one object deteriorating or decomposing into the things that make it up. Here's my example, and that is like a turtle egg getting ready to hatch, because inside there's a turtle, right? It turns into an empty egg and a turtle. So one thing turns into the things that make it up. Chris? Yeah, placement reaction. And again, you don't need to write that name down because you've already got it written down someplace.
Is that one of the 4?
No. It's one of the 5.
Where are you? Well, there's 4 spaces.
Yep.
I thought he wasn't going to.
Oh, new piece of paper before you do that, and then we'll just tape it on there. So next one, single displacement reaction that we've got. It's easy when you see it. It's harder when you read it like this, but it says it occurs when one element replaces another element in a compound. And it'll be easier to see once you see a chemical reaction that this takes place inside of. And as we go through it, here's what it looks like from a point of view, like the hint point of view, where you can figure out what type of reaction is occurring. And that is this. That when you look at one side of the equation, either the reactant side or the product side, that you're going to see an element and a compound on one side and an element and a compound on the other side. So in a single displacement reaction, you've got one element and one compound. Would you agree single is another word for one? Yeah. That's how I remember that. One element, one compound is a single displacement reaction. An example of that is here where sodium salt reacts with chlorine gas. Salt is NaCl and fluorine gas is F. And all that happens is the chlorine and the fluorine switch places when they come in contact with each other. So it turns into sodium fluoride and then chlorine gas. And that's a single displacement reaction. Two things swap places like that. So the picture I've got up here is representative of my experience in high school prom. You're welcome. You can already predict it. So, went with a date to the high school prom. Some other dude shows up without a date, and there I am walking away. So he and I kind of swapped places. Yeah, it was. You should have lived my life in high school. It was depressing. That is my representation of a single displacement reaction. One thing, here's the compound. Thank you. Here's the compound. There's the element. Element and compound, they switch places like that. So they wind up swapped. Your job now in your group is in 3 minutes come up with something other than this that can represent a single displacement reaction. You could talk about like food, like swapping food with somebody else. You could talk about clothing, like wanting a different piece of clothing on or something like that. You could make those work with this. But you got 3 minutes. So double displacement reactions occur when two elements switch places in a chemical reaction. It looks like this in terms of identification of it. The key is right here. And that is in a double displacement reaction, you always have a compound and a compound on both sides. So in a synthesis reaction, there was one thing, one product. In a decomposition reaction, there was one reactant. In single displacement, there was a reactant and a element and a compound on either side. In a double displacement reaction, there's a compound and a compound. Double means two, right? Two. Compound, compound. It's the only one that's like that. So my picture for it was that. There's plenty of examples that, we definitely are going to get to an example, Shayla. So here's my example. Here's my thing. It's like switching clothes, like with the shoes, except hats. This person has the hat this person wants. This gun's got the hat this person wants. So they swap hat. Double displacement. Two things, swapping places like that. So same thing. I can give you guys 3 minutes to come up with and plan out the picture that you plan to draw. For combustion reactions here, every single time in a combustion reaction there is the same product. No matter what's being burned or combusted, the end result is always the same. And that is, out of a combustion reaction, the only things that are produced are water and carbon dioxide, and that's it. Here's an example. CH4 is methane, like a flammable gas. Oxygen is the gas we breathe in. When CH4 comes in contact with oxygen, and it's got a heat source, it produces carbon dioxide and water. And no matter if it's methane, which is this gas, or if it's octane, which is the stuff you burn in your car, it's the same chemical reaction. It produces the same stuff. It's just that octane has a different amount of energy stored in it than methane does, or than butane does, or propane, or anything like that. Yes, ma'am.
You said stuff that catch on fire, right?
Yep. That's the gist of it. It's like if it can catch on fire, that's called combustion, essentially. And that is the end of your notes. We've got one last thing to do here. Can I flip this one or no?
No.
Okay.
No, please.
Okay. I'll wait.
Have you ever had tofu?
No.
I'm not that kind. Wait, did you?
Now you need to filter through Amy. That had absolutely no relevance to anything we're talking about.
She's agreeing.
Don't make me cause Lucas to filter Amy, who then would have to filter you. Yeah, we could have like a 3-level filter. All right. Yes. And as your homework tonight, on page 45, you just got to draw out the pictures that you planned out and then write a description underneath them. This shows it is a single displacement reaction because. Yep, the combustion one's out. That's the one we didn't do. So as we look at these, the question is, what type of reaction is it? So we'll use fingers here to show it, and your notes. As you look at this first one, look at the keys you highlighted in each reaction, and with a finger, 1, 2, 3, 4, or 5, tell me what type of reaction we're looking at there. Number 1, right here. Okay, so let me ask this question as I can see people working. BaCl2, element or compound? Compound. H2SO4, element or compound? So if you've got two compounds on one side, what type of reaction is it? I'm seeing people change their hands to this. That's double displacement. It's got a compound and a compound, double displacement. If we make our way down to number 2 with the fingers, what are we looking at? It's confusing sometimes, I get it. Yeah, that's a 3. That's single displacement. Zn, element or compound? Element and CuSO4. Element and a compound, you don't have to look at the other side. It is a single displacement. Number 3, what are we talking about? All right. Is it two things becoming one or one thing becoming two? Two things becoming one, which is synthesis. So this should be a number 1. Two things become one. This one, number 4, how many, and the key here is how many products do you have here? 1 product. What's the key on this one that tells you what it is? Right there.